Hello, I welcome you all in this presentation related with the subject materials processing fundamentals and practical. And today we will be starting the new topic that is based on the metal casting. You know that there are four common material processing methods like the casting, welding, forming and machining. In this course, we are basically talking about the casting, welding and the forming. Additionally, few other material processing methods like powder metallurgy and plastic molding will also be covered along with the practicals. So, here if we see in metal casting, this is one of the shortest route for making the product from the raw material to the final size and shape. Okay, few secondary processing may be needed to achieve the desired dimensional accuracy, surface finish and the properties in form of desired properties through the heat treatment. Okay. So, initially in this metal casting related thing we will be talking about first the approach of making the products and processing the material using the route of casting. Then what are the steps which are used, okay, and then how the materials and the casting, these two are related and the applications. Okay. So, we will try to initially understand the general overview of the any manufacturing route which involves like from the raw material. Okay, initially efforts are made to get the general shape and size which is close to the desired one, and for this primarily we prefer the primary shaping processes. Okay, primary shaping process. So, these primary shaping processes are casting, forming and powder metallurgy. Once we achieve the general shape and size which is close to the desired one, but it may not have the desired surface finish or the desired the accuracy. Okay. So, the desired to realize the desired dimensional accuracy and surface finish, these are further subjected to the secondary processing. Okay. In secondary processing involves machining or the heat treatment or welding like that. Okay. So, after the secondary processing, finish is desired finish and tolerance is realized through the grinding, honing and polishing. Okay. And then once the desired size, shape and finish is realized, will be the heat treatment is given for the property enhancement. And once this is done, then the things will be ready for the last stage activities like the painting, coating, packaging and followed by dispatching. Okay. So, in this presentation basically I will be focusing on the material processing, okay, by casting route. So, in the casting route what is the approach and how the things are made, about that we will talk little bit in detail first. So, let us say any particular part or component is to be made. Okay. So, it will have certain size and shape. Okay. So, initially first stage is to make the replica of the product to be made, replica of the product or part or the component to be made. This replica is known as pattern. This pattern can be made of wood or the metal or plastics depending upon the size of the component and the number of units to be produced, the dimensional accuracy desired. So, this making the pattern is the first step. This pattern is used to make the mould. Mould is basically kind of the cavity which corresponds to the shape desired shape of the component to be produced through the casting route. So, pattern is used to make the mould. Okay. Mould means it is the cavity of the shape and size of the component, close to the size and shape of the component to be produced. Okay. So, cavity is made. Once the cavity is made, this cavity can be of the made of the sand, means molding sand, or it can be made of the metal. So, metallic cavities are used in case of the die casting, okay, or it is made of the sand in case of the sand mold casting. Okay. So, the mold can be made of the metal or of the sand. So, this also depends on the number of units to be produced, that is one, or the quality of the component desired. Okay. So, once we are ready with our once the pattern is made, then we go for making the mold, and once the mold is there, then we choose the suitable material which is to be used for making the component. So, the next step is to get the raw material which is to be used for making the component. This raw material can be added with the alloying elements. This is one. This can be added with the other scrap material in form of chips. Okay. And all these things are added, mixed and melted. Okay. So, melting using the suitable heat source. Okay. Once the suitable heat source is used for melting the raw material, alloying elements and scrap, what we do? We get the we get the molten metal. Now, there is every possibility that this molten metal will have the impurities. Okay. So, we need to impurities may be in form of like organic component, inorganic components, or it can be in form of the gases. Okay. So, what is done basically, we try to treat the molten metal which has been realized using the suitable heat source for melting the raw material, other alloying elements and the chips. So, after this, the melting of the raw material is done, then the melt treatment is done. Melt treatment is done primarily to get the quality, to increase the quality of molten metal. Okay. How this quality molten metal is realized? This is realized by removing any kind of the gases, impurities like slag, or filtering out the the solid particles or solid material if it is there. So, basically what we do degassing for removing the gases dissolved, then we do the fluxing to take care of the impurities, and filtering to remove the solid particles which are there in the molten metal. So, the melt treatment will involve degassing, fluxing and the filtering, and once these three things are done, then we get the desired quality of the molten metal. Now, once we have got the desired quality of the molten metal, means there are two aspects. One is the how clean and good molten metal is there. So, quality of the molten metal depends on the two aspects. One is the temperature of the molten metal, and the second is freedom from the impurities. So, that freedom from the impurities is realized through the treatment, that is degassing, fluxing and filtering, and also its temperature is controlled. Okay. Once we have the molten metal of the desired temperature, okay, and the freedom from the impurities, then this is poured into the mold. So, the mold, so once we have already, because we have already got the mold, then molten metal will be poured into the mold. So, pouring of the molten metal into the mold. Okay. So, there are number of components in the mold that will facilitate the smooth entry and filling of the mold by the molten metal. So, molten metal enters into the mold smoothly and fills the mold as quickly as possible, so that the solidification can start at a time in the mold. Okay. So, after pouring, so the pouring is designed in such a way that the molten metal is filled with the minimum turbulence in the shortest possible time, and the molten metal being supplied is of the good quality into the mold. Once the molten metal has been supplied into the mold, the next thing that will happen is pouring of the molten metal. So, the next thing that will happen is the solidification, okay, because the molten metal will be having lot of heat. So, when it is poured into the mold, the heat is dissipated to the mold walls, and therefore, there will be reduction in temperature of the molten metal, and therefore, the change of phase will occur from the liquid to solid, okay. And therefore, the after pouring, solidification of the molten metal in the mold will be taking place. Once the solidification is over, the next thing is to remove the solidified part from the mold, okay. Once the solidification is over, then removal of the solidified part, okay. This solidified part is removed at correct temperature, so that there is no damage, breaking of the solidified component, okay. So, once this so this is removal, okay, this has to be removed. So, removal will depend upon the kind of casting process which is being used. In sand mold, simply the sand mold is broken, sand mold casting, sand mold is broken, okay, it is broken. But in case of the die casting, it is ejected, okay, it is ejected from the die to take out the solidified part or component from the die. Once this is removed, the next job is cleaning, okay, because lot of things and unwanted extra material is left into the solidified component. So, those are removed. So, the cleaning, and then after cleaning there will be inspection to see if the solidified component or the product which has been obtained through this route is in desired is of the desired size, shape, and the desired quality, desired soundness or not. So, there are a number of checks and tests which are done to ensure that the product has been made is as per the need and the specifications. So, now we will be talking that this general approach of the casting through the various aspects related to the casting. So, the casting is a process based on the simple approach of melting the raw material, that is including the waste material in form of the metallic chips, master alloys, pure metal, so that we get the desired composition. So, the raw material is obtained such that it is having the pure metal, master alloys, and so idea here is to realize the desired chemical composition of the metal, okay. And once to realize the desired composition using the, and then this raw material is melted using the suitable heat source. That will again depend on the kind of metal. Say if it is low melting point temperature metal, then we can use even resistance furnace, okay, but and the coal fired furnaces, gas fired furnaces. But if these are high temperature, then we use induction or arc based furnaces. So, the kind of heat source to be used will depend on the kind of the metal to be melted. So, depending upon the type of the material to be melted or material of the component, use the suitable heat source for melting. Once the molten metal is realized, its quality is enhanced that through the melt treatment. So, molten metal after melting is subjected to the treatment, which may be in form of degassing to remove the gases which can get dissolved into the molten metal during the melting. Fluxing is done to remove the impurities, alloying is done to adjust the composition as per the need, and the grain refiners are added to refine the grain size after the solidification of the casting, and so that the fine grain structured castings are produced, and cleaning and filtering is done to remove the all solid impurities which are there in the molten metal. Once we get the clean molten metal of the desired temperature, it is poured into the mold in controlled way. So, the pouring basin is one part of the mold, so that the molten metal is filled into the mold cavity of the desired shape, okay. And then when the molten metal is poured into the mold, it flows through the different channels, okay. The first is the pouring basin, okay. Then there is a sprue, okay. Then there is a runner, then there is a ingate, and finally there is a mold. and once the mold is filled, then molten metal goes to the riser. So, these are the different components through which the molten metal will be flowing and filling in before filling the molten metal into the mold and the riser. Okay. Each one plays a unique and a specific role in development of the sound casting. So, a complete channel from the pouring basin is through runner, in-gate, mold cavity to the riser through which molten metal flows during the casting is called gating system. Okay. So, this gating system must be designed appropriately so that the pouring basin helps to feed the clean molten metal. Sprue base supplies the molten metal without sucking the air. When it is flowing through the sprue, a runner feeds the molten metal at the desired locations if the casting size is very large before feeding it to the ingates, and through the ingates it is the entry point into the mold. So, molten metal goes into the mold through the ingate. So, this is also designed appropriately, and the mold shape certainly depends on the component to be produced, and that casting is riser is also to be designed so that it serves its purpose of feeding the molten metal to take care of the shrinkage of the molten metal during the solidification. Okay. So, a properly designed, therefore, each component pouring basin, sprue, runner, ingate, mold and the riser, everything is to be designed properly. So, a properly designed gating system produces the casting which is free from the defects coupled with the desired production rate. Okay. Now, what happens when we allow the solidification of the molten metal? Say molten metal has filled the mold cavity completely, then the heat loss from the mold wall will be taking place, and because of this heat loss, the temperature of the molten metal will be coming down. As soon as it comes down below the liquidus temperature, solidification starts. So, liquid to solid phase transformation starts. Initially, there will be mushy zone in case of alloys, and then the solidification will complete as soon as the temperature reaches to the solidus temperature. So, heat loss from the molten metal to the mold in turn causes the solidification by transformation of the phase from the liquid to the solid, and once the solidification is over, then product is taken out, cleaned, inspected, and the inspection is done as per the need of the quality and the kind of the standards to be followed. Now, what happens when we use the sand mold? We know that the sand mold offers the lower thermal conductivity as compared to the metallic mold. Okay, metallic mold. So, metallic mold, because of the higher thermal conductivity, extracts the heat, transfers the heat rapidly from the molten metal, and because of this difference in the cooling rate that is experienced by the molten metal during the solidification, especially, what we get higher cooling rate in the metallic mold, that results in the fine grain structure. Say this is the metallic mold. So, it will be producing the fine dendritic structure and equiaxial structure, while the sand mold, which extracts and transfers the heat from the molten metal slowly, that will be producing the coarser grains. So, the wider or larger interdendritic spacing and the coarse the grains are produced, and we know that the grain size plays a very important role in the mechanical properties. Grain size affects the mechanical properties significantly, and we simply have the Hall patch relationship for this, and according to that, and yield strength is found inversely proportional to the square root of the grain size, say average diameter of the grain. So, if we see this, then the metallic mold will be resulting in the finer grains, means smaller d value, and that in turn will result in the greater yield strength. Therefore, efforts are made to refine the grains through the addition of alloying elements, inoculants, grain refiners and number of other things which will help in realizing the desired the grain size, because cooling rate method cannot always be used, because especially if the casting size is very large, then it will be very difficult to achieve the high cooling rates, especially at the center of the casting or center of the mold. Therefore, we need to add the grain refiners. Okay. So, they will help us to realize the fine grain size in the casting. Okay. So, the following are the general steps which are used in the casting for shaping the metal by casting process. First, making the pattern, then pattern will be used for making the mold, and once the mold is ready, then the desired raw material is melted with the other alloying elements, master alloys, pure metal, so that the molten metal of the desired composition is realized. This melting is done using suitable heat source as per the metal to be melted, and then molten metal is subjected to the treatment, so that we get the quality molten metal, and that is done through the degassing, fluxing, alloying, and the grain refiners, the filtering, cleaning, etc. So, there are various steps which are done for melt treatment. This is particularly done for improving the quality of the molten metal, apart from controlling the proper temperature of the molten metal. So, here we can see suitable heat source. This is the, like, say, the furnace, and the heating is done in the furnace. So, molten metal is produced, and here we add the refiners and the flux, and the flux will react with the impurities to form slag, and then the tap is opened from the bottom to take out the molten metal in using suitable ladle, and then this ladle will be used to transport the molten metal to the mold. So, here by tilting the ladle, molten metal is poured into the pouring basin, and then from the pouring basin, then it will be going into the mold. This is one of the simplest way to express how things are done. And once the molten metal is filled in the mold, then the gradually, due to the loss of heat to the mold walls, the temperature will be coming down gradually, like, say, okay. So, the temperature, this grows even below the liquidus temperature before the start of solidification, and this is attributed to the undercooling. Then solidification will start, and then solidification will continue over a range of temperature. This is particularly true for the alloys having the wider solidification temperature range or solidification temperature range. And then once the solidification is over, then the temperature of the metal in the solid condition will be coming down to the room temperature. Okay. But if we talk of the solidification of the pure metals, then again temperature will come down in the beginning, then there will be undercooling, then solidification will start, and then solidification will complete at constant temperature. That is what happens in case of the pure metals and eutectic alloys, because eutectic alloys also solidify at constant temperature. Once the solidification is over, then temperature will be coming down gradually to the room temperature. Okay. So, this is about the solidification. So, pouring, so as far as the steps are concerned, here we can see the treated molten metal is poured into the mold cavity. So, this is to be done in such that the pouring is done so that the molten metal fills the cavity very smoothly, no turbulence, okay, no turbulence, and the no suction of air from the atmosphere, in order to maintain the quality of the molten metal, and no damage to the wall of the mold. Okay, because if the mold wall is damaged, then the shape of the component that is being produced will also get modified. Okay. So, the solidification, so once this is filled in after pouring, once the things are done, then the solidification will be happening, and during the solidification, you see, this can happen in case of the pure metal. This is the typical cooling curve which is obtained, and this is the kind of cooling curve which is obtained for the alloys. Okay. And once the solidification is over and things have come down to the room temperature or temperature low enough to have the desired strength in the castings, then the castings are taken out. You see, we do not take out the casting from the mold immediately after the solidification, because at a higher temperature the castings will be weak, low strength, and they will tend to get cracked, deformed, damaged easily, because the metal at high temperature is weak. So, what we do, we allow the cooling of the castings to a low temperature enough, so that the castings gain strength before taking out from the mold. Okay. So, the removal of casting is done at low temperature, which is low enough, so that the enough strength can be gained by the casting component. Okay. Then after the removal of the casting from the mold, it is clean, because there will be lot of impurities, fins, and the additional metallic things that will remain attached. So, we can use variety of methods for the cleaning purpose. like say it can be simply hammering, tumbling, or water jet, and the short pinning. Lot of methods can be used for removing the, or even thermal cutting to take care of the riser and other the parts and the other metallic parts which remain attached with the main casting. Okay, and once the cleaning is done, then things are inspected for the quality. So initially we do the visual inspections to have the general idea about the size, shape, and the size of the component. Okay, and then we can go for the other tests like soundness test, to find if there is a porosity, or if there is inclusion or any piping defect in the casting. So we can do suitable kind of the tests like dye penetrant test, magnetic particle test as per the metal, ultrasonic test, or even X-rays can be done to ensure that the quality of the casting is free from the defects, or there are any kind of the defects. And the occasionally what is done, also the compositional analysis is done, and microstructural analysis also done, and the mechanical properties, say hardness, and the tensile tests of the component being made is also done to ensure that whatever the castings are being made, they are of consistently of a given quality. Okay, so that is the part of the inspection thing. Okay, as far as the gating system is extremely important part of the casting. So we have to have the mold. Okay, the mold is made using the pattern. Okay, so the mold is made with the help of, say, in a simplest case, the two flasks, one the top flask and bottom flasks. There can be, for complex castings, there can be three flasks also. So the top flask is known as cope flask, and the drag flask, the lower one. And what we do, the molding sand is packed in presence of the mold, and then in presence of the pattern, and then pattern is taken out, and all these geometric features are created like pouring basin, sprue, sprue base, runner, ingate, then mold, and the core, and riser. So these are the important components. So once these features are there, then the two flasks are tightened and held together. Then the molten metal is filled with the help of ladle. When the molten metal is filled in with the help of ladle, how it flows, we can see here. It will be poured into the pouring basin, and then it will be going in through the pouring, through the sprue to the sprue base, and there is change in direction at the sprue base, and then it flows through the runner, and then through the runner it goes to the ingate, and then ingate, at the ingate it fills the molten metal into the mold cavity. Once the mold cavity is filled in, then molten metal goes to the riser. Okay, so each one plays an important role. Okay, here in the in development of the sound casting, there is a venting hole, so it will allow the escaping of the air which was there initially in the mold. So when the molten metal is filled in, excess air will be passed through this venting hole. Okay, and riser, whatever is the extra molten metal is there which was filled in the riser at the end. So this riser supplies the molten metal to the mold, especially when the shrinkage of the molten metal in the mold takes place. So the shrinkage of the molten metal in the mold is taken care of the riser, because riser feeds the extra molten metal to compensate the shrinkage of the molten metal in the mold. Okay, so the shrinkage basically takes care of the shrinkage of the molten metal basically from the temperature of the molten metal to the liquidus temperature. This shrinkage is taken care of by the riser. Okay, so now we will be talking about these the role of the different components. A typical gating system comprises pouring basin, sprue, runner, ingate, mold cavity, and a riser. Pouring basin is the first part of the gating system, wherein the molten metal is fed in from the furnace or from the ladle. Okay, pouring basin acts as a local reservoir of the molten metal, where impurities, solid particles are separated, and then clean molten metal is fed to the sprue. Sprue is a vertical channel through which molten metal goes to the runner via sprue base, wherein change in direction and the momentum of the molten metal takes place. So, this is usually made tapered and conical shape, because when we make it of the cylindrical shape, it allows the suction of air from the mold wall. Okay. Molten metal then flows into the different ingates through the runner as per the size and the design of the casting. So, we can have the many runners and in gates through which molten metal will be fed into the mold. That will depend upon the size and the design. If the size is simple, but size is large, then we will be feeding the molten metal from the different directions, so that the cavity can be filled in as early as possible. But if the size shape is complex, design is complex, then it is made the runners and ingots are designed in such a way that the molten metal can reach in all those the thin and complex geometrical cavities for filling the molten metal quickly and efficiently. Otherwise, there will be unfilled sections left in the complex shape and the thin section castings. Okay. Molten metal then enters into the mold cavity through the ingate. So, we can have large number of the runners and the ingates through which the molten metal will be fed depending upon the casting size and the design. The number and location of runners and ingate depend upon the size and complexity of the casting and the possibility of the formation of defects like cold shut, shrinkage cavity and unfilled sections, misrun, etc., and also the need of directional solidification. So, because we want that the solidification start from one and it goes to the another, and in order to make the casting free from the defect, and you see it goes to the riser after. So, molten metal after filling the mold goes to the riser after filling the molten mold cavity. The riser is an important part of the gating system which acts as a temporary reservoir of the molten metal to compensate the shrinkage on account of the liquid to solid transformation. Okay, as I have said, during the solidification, this section will the molten metal in this mold will be shrinking. So, whatever the shrinkage is happening, that the molten metal to take care of the shrinkage is supplied by the riser. Okay, to perform its role effectively, the molten metal in the riser must solidify after the completion of the solidification in the mold cave. Okay. Sometimes the castings need to be made with the internal features like this, They are not like the solid only. We need the geometrical features like a component with the hole. So, this kind of the internal features and the hole where the casting is not just solid, but it is having many internal features. So, to create the internal features during the casting, we need core, like say in this casting which is of like this, having a like say a hole like this. Okay. So, the molten metal will be filled in this section, and to avoid the filling of the molten metal in the region where we want a hole, a core is placed. So, core is made of the like say core sand. It offers the higher resistance to the temperature and higher to the stresses due to the metallostatic loading. So, the core sustains the more severe conditions of temperature and load. Okay. So, to realize the special internal geometrical features, a variety of cores are used which are fitted in the mold. So, here the mold is fitted, the core is fitted in the mold, and then core which is made of the core sand having the greater strength and greater refractiveness, resistance to the heat. A core is, since the core is surrounded by the hot molten metal, while the mold surface faces the molten metal from one side only. So, the core must show the greater refractiveness and strength as compared to the mold, because mold wall faces the heat just from one side, while the core is completely submerged in the molten metal. So, the heat, the severity of the heat and pressure is much higher in case of core. So, that is why the core must be made of the material which is of the greater refractiveness and of the greater strength. Okay. What if our the casting being made is defective, like say, and it is very common, like the castings may have the porosity, inclusions and cracks. Okay. So, if these are there, then what we do, like inclusions, cracks and porosity, there are two general approaches that we can use. One is the simple remelting using there can be multiple approaches, these are the one of the like say the newer and novel approaches. So, what we can do is using the suitable heat source like TIG arc, we can melt up to certain depth, so that the melting the thin layer of the casting surface will help to remove all these inclusions, porosity and cracks, and thereafter on resolidification we will get the sound surface or near surface regions wherever the melting remelting has taken place. Another one, we can use the solid state process like friction stir processing. So, what it will be doing? It will be causing the controlled plastic deformation of the near surface layers with the help of a non-consumable tool and shoulder. So, friction stir processing with the help of shoulder and pin, what we do? Controlled surface layer deformation is realized, that will be collapsing all these porosities and cracks and breaking the inclusions, and so their distribution will be enhanced, and that in turn will be leading to the development of sound casting. So, initially we may have the defective component like this, but when we process using either a controlled remelting using the TIG arc or controlled plastic deformation using the friction stir processing, we get the sound casting like this. Now, I will summarize this presentation. In this presentation, basically I have talked about the approach of casting process and what are the major steps related with the casting process, and what is the role performed by the gating system in development of the sound casting. Thank you for your attention.